Hello, is it audible?
Yes, ma'am. It is audible.
Okay. So just that those who have downloaded that one, the material, you can open or I'll open directly.
Ma'am, one request actually.
Yes.
Because the RM subject is very new to me and the students also. So can you go little bit slow because it's a little bit hard
Yes,
to.
yes, I know that one. If I'll do that, means actually the 10 classes, I have to complete the 4 units. Okay. So it is very difficult. I know that one. It will be very difficult for you also. But yeah, I am taking only 10 classes. Within that, there is gap. Means Wednesday, Thursday, Friday. You can refer that whatever I am teaching here. I have some. I have also provided you the material, and you can do. Otherwise, anyway, I have to cover the entire syllabus within the 10 class. So actually 4 units, it will take minimum 40 classes. So it is very difficult to complete the whole syllabus within these 10 classes. That's why obviously it will be very fast. Only thing is that you have to get information in the classes, and it is not possible to clear each and every doubts and clear means if I go slow, then actually only 1 unit it will be completed clearly, or more maximum to maximum 2 units. If you want that one, then I'll go for that, opt for that.
Okay, ma'am. As per the exam, what the input on the unit you will complete so that it will
You
be
have
helpful.
to means in the 10 within the 10 classes you have to cover all the units. Means you have to get some idea, then you can do. You have that number, contact number, you can ask me anytime. If you are suppose I am free at that time, I will make you understand. Okay.
Thank you.
That's why I have given you the contact number and mail ID also. So it is not like that only I'll take 10 classes and it will be over. If any more doubt, the student can ask me freely. Means that you have that phone number, that mail ID, you can write the question and I'll give the answer. Or any tips, any way to how to solve the problem and which book you refer. After the class also you can ask me. It is not like that. So you don't think means I'll not make you understand whatever it will come to your mind. Okay. So now we'll continue. So now we'll continue whatever. Just I'll share it. I think we have completed Z test and T test one. T test for single mean we have completed. No. T test for single mean we have completed.
Yes.
Okay. So now going to share you. Just wait for that. So the means material it is visible now.
Yes, ma'am. It's visible.
Okay. So which page we have completed? Just I will go to that one. So T test for single mean it is already completed. Now we'll come to T test for single mean. Just I am reviewing again. T test for single mean and Z test for single mean. What is the difference? Z test for single mean, it is that means Z test for single mean, it is that the suppose it is for only single population and you have drawn the single population and you have drawn the single sample. But if it is more than just wait, one who is calling. Wait 1 minute. No, Nami ke sikasini. Nami, sikasini. Tapi aku sakit. Ne. So The Z-test and T-test, what is the difference? Z-test you have to use for large sample and T-test you have to use for small sample. Okay. So small sample means it is less than 30. It is less than 30 anyway. So if it is less than 30 and it is single mean, how to draw the sample from the population? That suppose only mean it is given and some population standard deviation it is not given, but it is less than 30. Okay, sample mean is given, population mean is given, and instead of population standard deviation that is your sigma, and sample standard deviation that is your small s. Okay, so in that case you have to use T-test. The formula is x bar minus mu divided by sigma by root over of n. So one thing it is important for you that whatever I am teaching here from the material only, on that day or next day you have to practice the same problem by yourself. Then only you can understand what I have taught. Okay, and you can cope with the next class. Otherwise you cannot cope me, because actually whatever we are discussing here, it is related to the previous. If you will not do the previous problems, you cannot understand or you cannot exceed further. That's why it is very important that whatever the discussion I am doing, doing here, and the material it is also with you, and any statistics book you follow, and you practice the same problem whatever you have discussed here. Okay, then only you can understand. अरे मैं ऑनलाइन रे क्लास नउची, ऑनलाइन रे क्लास नउची, तो मैं नमी भी फोन करो रखिली. So this is the important thing that you have to understand. So next we will discuss about that. I think already we have discussed the problem related to T-test for single mean. Yes or no? This problem we have discussed. The next problem we will discuss, and we'll proceed further. T-test for 2 T-test for 2 mean. Okay. So this problem already we have discussed, and I have told that what is the procedure. The procedure to find out that the tabulated value for T. All of you have got how to get that one. The tabulated value for T, degrees of freedom, and n minus 1. And this is the second question. This second question, a salesman is expected to effect an average sales of 3500. A sample test is derived. A particular salesman made this one. So this problem we have I think in the last class we have discussed, no? Hello. This particular problem already you have solved, no? You are not saying? Salesman problem we have solved, I think. We'll go to the next. This one also. A group of 5 patients. This one we have solved or not? Anyone tell me? A group of 5 patients treated as medicine A and B. This is the table. This is the T-test for 2 means. I think this one we have not discussed, no?
No, madam.
Okay. A group of 5. This is the T-test for 2 mean. Okay. T-test for 2 mean. Means suppose 2 population it is there, and 2 samples we have drawn separately. A group of 5 patients treated with medicine A, that is one sample, medicine A, and medicine B, that is another sample. So medicine A, the sample weights are 42 patients, 5 patients weight, 42, 39, 48, 60, and 41 kg. Similarly, second group of A, 7 patients, it is not necessary that sample A, whatever the sample size, population sample B, the sample size it may be different. Okay, it is not necessary that N1 is equal to N2. N1 may be equal to N2, N1 may not be equal to N2. Okay. So in this case, first group contains how many samples? 5 samples. Second case, it is 7 number of sample, means B, medicine A and medicine B, different patients we have taken, okay, who are using medicine A, who are using medicine B. Anyway, so now we have to check, and after that the weight we have taken, these are the weights. So do you agree with the claim that the medicine B increase the weight significantly? That means we have to check whether medicine B, after taking the medicine B, the weight of the patients, it is increased or decreased. So first we'll take that null hypothesis. Here there are 2 sample, means 2 population we have drawn. From the 2 population we have drawn the 2 samples. So 2 samples we have taken that mu1 is equal to mu2. So in case of 2 sample testing, the null hypothesis you have to write mu1 is equal to mu2. Since it is mentioned in the question that whether after taking the medicine B, the weight of the patients it is increased or not, that's why you have to take, instead of taking that mu1 is equal to mu1 is not equal to mu2, for alternative hypothesis, you have to take mu1 is less than mu2. Why? Because it is given that medicine B increase the weight of the patient significantly or not. If it is mentioned medicine A, then you have to write mu1 is greater than mu2. So alternative hypothesis, if it is not mentioned anything increase or decrease, whatever, then you have to write mu1 is not equal to mu2. So alternative hypothesis already I have told that it may be not equal to, it may be greater than equal to, it may be less than. Okay, it may be greater than, it may be less than. So according, suppose it is not mentioned anything, you have to write total test that is not equal to. If it is mentioned in the question, then you have to go for either less than or greater than according to the question. So since it is given medicine B is increased, that's why mu1 is less than mu2. Anyway, so next we'll come to level of significance. So level of significance, we have taken 5% level of significance, and formula it is T is equal to a test statistic formula x bar minus y bar divided by root over of a square into 1 by n1 plus 1 by n2. So here x bar minus y bar it is given. So x bar and y bar, it is not actually given, only the data set given. So data set given means for x, we have to take the medicine A, and y we have to take medicine B. Okay, so what is the formula for S? So this is the formula that x bar minus y bar root over of a square. So what is the formula for a square? A square is equal to 1 by n1 plus n2 minus 2. Okay, and within bracket summation x minus x bar whole square plus summation y minus y bar whole square. Like this way you have to write. Okay, so first we have to calculate x bar y bar, then we have to go for x minus x bar whole square, y minus y bar whole square, then summation. So it is very difficult to get that x minus x bar whole square, because suppose x bar is coming, x bar means you know that mean suppose mean, then it is very difficult to get the deviation and square. All it will coming in the fraction means decimal form. That's why to avoid that type of difficulty, summation x minus x bar whole square, the formula you can write directly, summation d square minus summation d whole square divided by n1. So what is your small d? D is your x minus assumed mean. Okay, similarly for summation y minus y bar whole square, instead of that formula, you can write summation capital D square minus summation capital D whole square divided by n2. So what is your capital D? Y minus assumed mean. So that is your x minus assumed mean. This is your y minus assumed mean. So like this way you have to proceed further. So how to calculate that one? This is the calculation procedure in the tabulation form. So x, that is your weight of 5 patients, y is your weight of 7 patients. So like this way, D how to get? D is your x minus assumed mean that is your 48. Similarly, assumed mean how to choose? That lowest plus highest by 2 approximate value of that means 49.5. The approximate value of that in x it is 48. That's why assumed mean you have to choose it as 48. Then you have to calculate D. After that D square. Okay. So similarly for the y also you have to do like that way. Similarly the value you put in the formula, directly you will get the value for summation x minus x bar whole square, summation y minus y bar whole square, Similarly, you'll get S square. S square is equal to 1 by n1 plus n2 minus 2 within bracket summation x minus x bar whole square plus y summation y minus y bar whole square. Then you put the value, get the answer. So you'll get t is equal to the formula x bar minus y bar divided by S square 1 by n1 plus 1 by n2 root over. So then you put the value, get the answer directly. Whatever the answer you have got, that means minus 1.7. So you have to take the absolute value. Always I have told that calculated value, whatever the negative value it will come, you have to convert it into positive, because absolute value you have to take. So it will be 1.71, which is then you have to go for calculated value. Sorry, tabulated value. Tabulated value means, always I have already told, either you can say tabulated value or you can say critical value. So critical value at 5% level of significance with n1 plus n2 minus 2 degrees of freedom. So in that case, in case of single mean, always you have to remember, in case of single mean, what is the degrees of freedom? Degrees of freedom is that n1 plus n2 minus in case of single mean n minus 1, because only single mean, single population, single sample it is there, but here there are two population, two sample. That's why it will be n1 plus n2 minus 2 degrees of freedom. So what is your n1? 5. What is your n2? 7. 5 plus 7, 12. 12 minus 2, that is 10 degrees of freedom. So 10 degrees of freedom, 5% level of significance. So what is the tabulated value? You have to see the table, T table, and you'll get the 2.2281. Today only you check whether it is equal to, with degrees of freedom, 10 degrees of freedom with 5% level of significance, whether it will be equal to 2.2281 or not. Then you have to go for comparison. Since the calculated value of T is 1.71, which is less than 2.2281, that means we may accept the null hypothesis. We may accept the null hypothesis. Okay. So we may accept the null hypothesis means what? Taking medicine A for all the patients, whatever. Taking medicine A for all the patients and taking medicine B for all the patients, the effect it is remaining same. There is no change. Means we cannot say that whatever the alternative hypothesis you have taken, that after taking the medicine B, the weight of the patients it is increased. It is rejected. This statement is rejected. That means medicine A and medicine B are remaining same. The effect of medicine A and medicine B for the patients in that other groups, two groups, it is equal. So this is the conclusion we can draw, since the calculated value is less than the tabulated value. So we may accept the null hypothesis. I think all of you are clear from this particular problem.
Yes,
hello. All of you are clear for this particular problem? Please, you tell me.
Yes, madam.
Okay. Next we'll come to the other problem, means another one problem. So this one also same type, a random sample of 20 daily workers of a state A and state B. Like that, all the information it is given. State A are earning more. More means mu1 is greater than mu2. You have to put. Okay. So whatever the data it is given, I have written x bar given, y bar given, n1 given, n2 given, s1 square given, s2 square given. Everything it is given to you. Okay. Then next we'll come to the null hypothesis, that is mu1 equal to mu2. Okay. So alternative hypothesis already I have told. Here it will be state A and state B. State A and more you have to check. That means mu1 is greater than mu2. If it is not mentioned anything in the question, you have to write mu1 not equal to mu2. Then alpha percent, that is your 5% level of significance. What is S square? S square, the formula, suppose small s1 square and small s2 square it is given. Small s1 and small s2 means sample standard deviation, sample variance for first sample and sample variance for second sample. And what is your capital S square? That is your population mean square. So here you have to use the formula for population S square. That's why based on that small s1 square and small s2 square, what is your capital S square? The formula is n1 s1 square plus n2. Here the most important thing is that for different formula, different formula or different test, different formula, you have to write a different type of hypothesis and different type of formula also. It is very important that for different tests of and applications, you have to write the hypothesis differently and formula also differently. That's why it is very important that you have to practice yourself for which test, what is the null hypothesis and what is the formula. That is the most important thing. According to the condition only, this formula you have to put. Okay, so SQR the formula I have written, then you have to go for t-test. So t-test is equal to the formula, you know, x bar minus y bar, root over of s square into 1 by n1 n2. So you put the value and get the answer directly. Everything it is given to you. There it was not given, that's why you have to calculate. So since the data it is available for you, directly you put the value and finally you are getting that t calculated value is 1.69. T calculated value is 1.69 and t tabulated value is 5% level of significance. What is the degrees of freedom? N1 is equal to, I think, N1 is equal to 20 and N2 is equal to 20. That's why it will be, just wait. What is your N1 for this particular problem? 20, 20. That means 20 plus 20, 40 minus 2. It will be what? It will be 38. So 38 degrees of freedom, 5% level of significance. What is the t tabulated value? 1.645. So since it is 1.645 tabulated value, now you just compare the calculated value and tabulated value. You'll get calculated value is more than the tabulated value. So we may reject the null hypothesis. Since we are rejecting the null hypothesis, that means we are accepting the alternative hypothesis. So what is the alternative hypothesis? That mu1 is greater than mu2. That means worker A earn more. We are accepting that one. We cannot say that worker A and worker B, their earning capacity, it will be remaining same. We cannot say because we are rejecting that. That's why in whole population, we can say that worker A group are earning more than worker B group. You are getting my point? All of you are clear? In the state means worker A group means state A, all the workers in state A, all the workers earning more in the state B, because you are accepting, rejecting the null hypothesis. Alternatively, we are accepting the alternative hypothesis. So I think all of you are clear.
Yes, ma'am.
Very good. The next will come to, so t-test for single mean it is over, t-test for 2 mean it is over. Last one, pair t-test. Pair t-test means what is the difference between t-test for 2 mean and t-test for pair t-test. The difference is that pair t-test, the sample size for 2 different samples must be equal. Equal means for the comparison cases, you can use this pair t-test. It is very important, and for any type of comparison cases, you can use this pair t-test if it is a 2 sample or 2 population. If it is a 2 population and you have drawn 2 samples, that's why it is known as pair t-test. What is the best example? The real life example I am giving you. Suppose you have joined DDC for pursuing or for getting the MBA degree. So before MBA degree, you have suppose you are giving the entrance test. Okay, entrance test. Before doing that MBA, suppose 100 students, they have given not 100. Here I am taking less than 30, means from a small sample. Less than 30 means small sample. Suppose 20 number of students before joining, you have given the entrance test and you have scored out of 100, whatever the score you have got, that it is mentioned. Then after doing the MBA, that means you are trained. So same 20 number of students, again I am conducting another one entrance test, same 20 number of students, and they have scored another marks of out of 100. So these are the previous MBA degree. What is the knowledge they have got? What is the knowledge they have? That means the marks we have got 20 different marks. After doing MBA or after training program, same 20 number of students, another entrance test we have conducted, and another 20 marks we have got, 20 different marks. So now we have to check whether that training program or MBA degree, it is helpful for gaining the knowledge or not, enhancing the knowledge or not. That you can test by using this parity test. Okay, this is known as comparison, or for comparison purpose, we have to go for parity test. Means here 20, the same students, N1 is equal to N2. We cannot take the different sample. The sample size must be equal, and the same students score before the training program, after the training program, before installing digitalization in any institute, whatever the means output, after that, what is the output, means any type of comparison cases, you can apply this parity test. So now I am giving you another one example related to that. What is the formula for t-test, for parity test? Here the null hypothesis also remaining same, mu1 equal to mu2, mu1 not equal to mu2, alternative hypothesis. If it is mentioned that whether whether the training program means affecting, then mu1 is less than mu2. If it is not affecting, then mu1 is greater than mu2. So like this way. So that alternative hypothesis, null hypothesis I have told. Next, next you have to know that what is the formula of t. T for this case, d bar divided by capital S by root over of n, or you can write d bar divided by s square by n root over. So what is your d bar? What is your d? D means difference between the first sample and second sample data. First sample data, that is your x. Second sample data, that is your y. So d is equal to x minus y. Okay, d bar, that is summation d by n. Because you know that n1 is equal to n2, that's why you can directly write n. Okay, so d means whatever the previous data it is given, and after training program the data must be given. So then you subtract it, you will get d. D is equal to x minus y. So after getting this, you'll get the what is your S square formula? I have also written a simple formula. Just you have to remember second formula, always you have to apply 1 by n minus 1 within bracket summation d square minus summation d whole square divided by n. This formula always you have to use for calculation purpose. So now I am giving you an example, and degrees of freedom here for this case n minus 1, because n1 is equal to n2, that's why it will be equal to n. So the degrees of freedom is n minus 1. But for previous case, it is n1 plus n2 minus 2. That previous case n minus 1. Here also n minus 1. At 5% or 1% level of significance, you have to test for that. So this is the example. An IQ test was conducted to 5 different persons before and after the training program. Okay, so these are the result. IQ before training, IQ after training. IQ before training, that is your 1, 2, 3, 4, 5. IQ after training, that is your same students. These are the marks. First one, it is 110, 120, 123, 132, 125. After training, 120, 118, 125, 136, 121. Now we have to check whether the training program affecting or not. Okay, there is any change, means affecting or the not. That means mu1, mu is equal to mu x is equal to mu y, or you can write mu1 is equal to mu2. Alternative hypothesis, mu1 is not equal to mu2. Okay, so next, the level of significance, it is given 1%. That's why you have to write 1%. Then the value x and y you have to write, and you have to calculate d. D, that is your x minus y difference. Then d square you calculate, summation d square you calculate. Then d bar is equal to summation d by n, that is your mean, minus 2, and s square, the formula already I have told. Just you put the value, get the answer. So after that, you have to calculate t, that is your d bar divided by root over of s square minus s square by n. So that you put the value, get the answer, that is minus 0.81. So it will be the calculated value. You have to take absolute value 0.81 instead of minus 0.81. Then tabulated value at 1% level of significance with 4 degrees of freedom, the value it is 4.6. Okay, 4.6. Now the conclusion, from it you can compare that calculated value is much more less than the tabulated value. That means we may accept the null hypothesis. So here you can conclude that the training program doesn't affect the students before training program, whatever they are scoring after also training program, the same scoring they are getting. That means the training program, it is not affecting the students' knowledge IQ level. So I think all of you are clear. After understanding this particular problem, what is the meaning of parity test? Hello? All of you are getting or not? Hello?
Yes, yes, madam.
Very good. Then you will come to the next problem that you can understand by yourself. This is the task for you. You read by yourself and you can practice whatever. So next problem, just I am skipping because the same type. Then two mean, difference between two mean, already you have discussed the difference. This one already you have discussed. And now it is coming t-test for correlation coefficient. So all of you have known the correlation coefficient, how to calculate. It is not necessary because it is little bit, I think it is not in your syllabus. We can skip this one. Directly I am coming to, these are some problems you have to practice by yourself, the pair t-test problems. Today only you have to practice all the problems, whatever I have solved for t-test. Okay, z-test and t-test, you have to practice yourself. If any more doubt from any type of problem, you can ask me up to this page. Okay, now correlation coefficient, some problems I have solved. If you have known about the correlation coefficient, then only I'll teach, otherwise I'll skip this one. Please you tell me. You have idea related to correlation coefficient? Because I think it must be there in the second semester statistics paper. Correlation, regression, you have an idea? Hello? Otherwise it is not so important. I can skip this one. Next I'll come to chi-square test. It is very, very important for you. So today we'll discuss the chi-square test. Okay. Just wait for 2 minutes. I am taking the medicine. This is the one of the most important parametric and non-parametric test. So chi-square is denoted by this type, chi-square. Okay. There are 3 important applications. So for z-test, there are also applications, z-test for single mean, z-test for two mean. Similarly for t-test for single mean, t-test for two mean, pair t-test, and t-test for correlation, but we are not discussing. It is not so important. Then chi-square test, also 3 different applications. One is your chi-square test for goodness of fit, chi-square test of independence of attributes, chi-square test for population variance. The most important application is the second one. First one also little bit, but second one, it is very important for all the social science researcher because they have to use this one frequently. Otherwise means this is one type of non-parametric test. Chi-square test of goodness of fit also non-parametric, but parametric is chi-square test for population variance. So first we'll discuss chi-square test for goodness of fit. So in case of chi-square test of goodness of fit, first I'll make you understand what is the meaning of goodness of fit. So here, suppose the number of accidental case, and here just example, you can understand the means when you use this chi-square test of goodness of fit. Suppose you are recording the accidental case in any busy road. Okay, suppose here the number of accidental case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 sample days, each and every day, 10 days, you have collected the information that on a busy road, any particular busy road, how many accidental case it is going on for a month. Here are this frequency agreement with the belief that the accident conditions were the same during the 10-month period. Means, sorry, these are the monthly data, not daily. So for each month, first month it is 12, second month it is 8, third month it is 20. So whatever the data we have collected, monthly data for accidental case, whether it is true or false, that you can check, because this is our observed data only. Whatever we have collected, that we have got. Okay. So whether it is true or not, how to get that one? How to prove that one? By using that chi-square test of goodness of fit, you can test that whether whatever you have collected or observed data, whether it is true or not. Okay. So this one you can go for testing by using that chi-square test of goodness of fit. So whatever that you have collected through observation, that is your O, observed data, and E is your expected data. So how to get that expected value? Expected value, the formula is, I have written here, summation O by N. N is your number of month, number of sample, that is your 10. So sum of O is equal to 100, 100 divided by 10, it is 10. That's why for each and every cases, you have to write 10, 10, 10, 10, like that. O and E. O must be given to you, but E, you have to calculate by using that formula. Okay. Then you have to calculate O minus E whole square, O minus E whole square by E. This is why, because the formula is like this. So what is the null hypothesis for this case? So chi-square test of goodness of fit, null hypothesis is different. We have to test that whether we have observed the data for 10 months, it is true or not. That means whether sum of E or sum of O is equal to sum of E or not. Observed and expected, it is equal or not. That we have to check. So H1, that is your sum of O, is not equal to sum of E. Okay, sum of O is not equal to sum of E. Then alpha percent, that is your 5%. Alpha percent, that is your 5%. So what is your chi-square calculated value formula? Sum of O minus E whole square by E. Already you have calculated through table. You have got from the table. Sum of O minus E whole square by E. That is your 26.6. Okay. So that value you have to put. So that value you have to put. So directly you have got from the table, calculated chi-square is equal to 26.6. That one you have to write here 16.919. Okay. Then what is the tabulated, sorry, 26.6 is the calculated value. Tabulated value at 5% level of significance. What is the degrees of freedom here? N minus 1. N is your 10, 10 minus 1, 9 degrees of freedom. The calculated value of chi-square. Don't follow the T table. You have to follow chi-square table, another different table. It must be there in any statistics book you find, you will get. Okay. In the last page, chi-square table you follow, you'll get 9 degrees of freedom, 5% level of significance. The tabulated value is 16.919. So you can say that since the calculated value is more than the tabulated value, we may reject the null hypothesis. That means whatever we have observed, the number of frequency of the bike accidental case on a busy road, it is not true. It is not true. So I think all of you are clear. This chi-square test of goodness of fit. So like this, some questions I have solved here. You can practice. This is the SPSS. How to go for SPSS software. How to use that one. This is the problem, means that I have solved here. So next, it is coming chi-square test of independence of attributes. So chi-square test of goodness of fit, all of you are clear? The observed frequency must be given to you. Okay. All of you are clear? For chi-square test of goodness of fit, please. Anyone can say whether you are getting that problem or not? Hello? 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 Hello?
Hello. Ma'am,
Yes.
clear, ma'am.
Previous problem you are getting?
Yes, ma'am. Yes, ma'am.
Very good. Then next we'll come to the chi-square test of independence of attribute. So independence of attribute, this is the most important one. All the researchers, means social science researchers, they have to use this particular test. They have to use. Okay. So here one example I'm giving. Independence of attributes means, suppose there are two variable. Here I have taken stream is one variable, gender is another variable. So stream is MBA students I have taken and MCA students I have taken. Gender, male and female. So for MBA, how many students I have taken? 50 number of students. Out of that, 20 are female and 30 are male. Similarly, for MCA, female 30 and male 25. The total 55 students. So these are the data set. The total number of students from different stream we have taken. Now I have to test whether what you have to test I have written here. Just wait. So whatever the data it is given, means 20, 30, 30, 25. All these are the observed frequency. Observed frequency means you have collected that from the collected data only. That from MBA it is 20 for female, for that same MBA 30 for male. Similarly for MCA 30 for female, 25 for male. That you have collected. So what you have to test actually? What is your objective? Your objective is to test the two attributes, means stream and gender, whether they are independent in nature or dependent in nature. That means the choosing of stream, MBA or MCA, it is depending upon the gender or not. Means male and female, whether the male, those who are male, they are opting for MBA or MCA. Those who are female, they are opting for MBA. Means gender is the one variable, stream is another variable. That means choosing of any stream, it is depending upon the gender or not. That you can study through chi-square test of goodness of chi-square test of independence of attribute. So here we are saying that two variables, stream and gender, these two variables are independent. Means choosing of any stream, it is not depending upon the gender. Okay. It is not depending upon the gender. We are saying that it is not depending. That we have to prove whether it is true or not. So how to prove that one, or how to test that one? By using chi-square test of independence of attributes, you can go for testing whether the choosing of any stream, it is depending upon the gender of any university. A university, suppose population data, we have taken the sample data of 105. The total data is 50 plus 55, 105 number of students. Those are coming from the background MBA and MCA. And now we are saying that whether we are testing that whether in the university that whatever the MBA and MCA students they are, it may be 500 or 1000 the population size, but we have taken only 105. Through that we have to conclude that whether the choosing of the stream and the choosing of the stream, it may MBA or MCA, it is depending upon the gender or not. It is not necessary that stream, the number of stream, it is equal to the number of gender. It is not like MBA, MCA, mathematics, PG, whatever you can add, engineering, BTech, whatever, or MTech, MPhil, whatever you can put, all these the variable number of data in single variable under the stream, it may be more than that. It is not like that always 2 cross 2 or means number of row must be equal to number of column. It is one type of matrix. Here it is 2 cross 2. Stream is 2 and another variable gender is 2. It is not like that always. It will be 2 2 or 2 3 3. It may be m cross n. Okay, number of row may not be equal to number of column. So whatever it is, that is your observed data. It must be given to you, observed frequency. Okay, you have to calculate the grand total. Like that, grand total already I have calculated. 20 plus 30, it is 50. 30 plus row wise grand total and column wise total you calculate, and then grand total. Okay. So because already it is known that observed frequency, now we have to calculate the expected frequency. So how many observed frequency we have? 4, 20, 30, 30, 25. You can go for row wise, you can go for column wise. It doesn't matter. 20, 30, 30, 25. You can take. So then this is your observed data. Now you have to go for expected data. So what is your expected data? Expected data, how to calculate? Expected data you can calculate. That means 4 expected value you have to calculate. In this case, how to calculate the expected value? The formula is, suppose you have to calculate expected value of this 50, first 50. Sorry, you have to calculate the expected value of first 20. MBA and female, it is 20. So expected value of 20 is equal to the row total of that is 50. The column total of the corresponding 20 is 50. That means 50 into 50 divided by grand total 105. 50 into 50 divided by grand total, that is your 105. Okay. So we are getting the value, expected value of 20. Similarly, for all cases, you have to calculate the expected value in that way. So here I have written the formula, row total into column total divided by grand total. So like this, you have 4 expected value we have got for each one. For first 50, then another 51, 2, for 2, 1, for 2, 2. So after that, you have to frame the table, because the formula for calculating chi-square calculated value, that is your summation O minus, same formula. Whatever you are doing for the goodness of it, the same formula here also, chi-square calculated value, that is summation O minus E whole square by E. Okay, so first you have known that O, then you have to calculate E, O minus E whole square, then divided by E, and you get the summation, you get the result of calculated value. Then you go for tabulated value. Here the tabulated value, that is degrees of freedom, is different, because row and column we are taken. That's why number of row is denoted by M, number of column is denoted by N. So the degrees of freedom, it will be M minus 1 into N minus 1. That is the degrees of freedom. So M minus 1 into N minus 1. What is your M? 2. 2 minus 1, that is your 1. Column 2, 2 minus 1, that is your 1. 1 into 1, that is your 1. So with 1 degrees of freedom, 5% of level of significance, what is the tabulated value? That we have got here. That we have got here, 2.21. And the tabulated value we have got at 5% level of significance, 3.841. So that is the calculated value. This is the tabulated value. Now you compare it. So we are getting that it is less. That means we may accept the null hypothesis. So what is your null hypothesis? Null hypothesis is of sum of 2 variables or 2 attributes are independent. Means choosing of stream, it is not depending upon the gender of the students. So I think all of you are clear from this particular problem. Any more doubt? Please. From these two, from this particular problem, any more doubt?
No, madam.
Okay. So like this, you have to solve so many problems I have solved here. You have to practice yourself. Next class, if any more doubt, you can ask me any page number you tell me, so that I'll clear your doubts. Whatever it is given here, okay? The problems you have to practice by yourself. So here you can check 3 number, means row there are 3, and column it is 1, 2, 3, 4. 3 cross 4 table. Okay. So like this, your observed frequency it is given, and you have to calculate the expected frequency, and you can practice yourself so that you can understand that how to solve the problems. And whenever you do for project, whenever you go for submitting the project, you can use all these methods. That's why it will be helpful for you at that time. Okay. If any more doubt, you can ask me also anytime. That doesn't matter. So if any more doubt also, now you can ask me. I think today this much, otherwise I cannot understand more. And so if I'm giving you 2-3 minutes so that you can ask me the doubts. So how for up to what step, what page number you have to complete yourself till tomorrow? This is a 59 page. 59 page you have to cover by yourself. If any more doubt, you can ask me tomorrow, because tomorrow I'll take the class in same time. Today in the class, if any more doubt, you can ask me. I am giving you. Hello. Any more doubt? Hello? Hello?
No, madam.
No doubt. So I may leave now. So only it is left, I think, app test and Chi-Square test, another one application it is there. Then app test it will be there. Then I think the test, the sampling distribution, it will be over. So in next class means tomorrow, we'll discuss another thing and another method, that is whatever the multivariate analysis, regression analysis, whatever it is there, we'll discuss that one. And at that time, I'll show you the means material. And in the meantime, only tomorrow I'll send you the material. Okay.
Okay, ma'am.
So I think I should leave now.